sound will be long. Other than that, so what is the exact meaning of reverberation?
Reverberation.
Yeah, tell me. What is the exact meaning of reverberation? Yes.
Could you repeat, sir?
Reverberation. We learned about reverberation in the last class. So, what is reverberation? I said sound persists. Remembering?
It'll sound is long.
Yeah, I said sound.
Yes, sir.
Sound persists. Remembering this?
I do remember that.
Okay, so I'm just let me share this screen for you. Give me a second. Is it visible? So we learned reverberation as sound persist. Am I right? Remembering?
Yes, sir.
Okay. So that is what we call it as what actually the word?
Could you repeat?
Reverberation. Reverberation mean by sound persists. Okay. So I told you that when we are cracking a small balloon and when we crack a number of balloons together, what will happen? You can hear the sound for some time and it reduces, it goes like that. In the other side, just breaking one balloon in a single click, it just give with one sound and then goes away. Am I right? So reverberation is nothing but
Yes,
sound persists. Okay. Okay. Now let's understand today's class. One topic called production of sound. Okay. What is production of sound? All of you, hope all of you are listening to me. Don't waste my time and don't waste your time. Listen to me very carefully. So we are going to do production of sound today. Okay. Let us understand what is production of sound.
So we did this last class about vibration.
Reverberation, I told you.
No, we also discussed how when object vibrates, that is when sound is produced.
No, but that's okay. But let us see in detail what is the production of sound. Okay. Let's see. Production of sound. So production of sound, we know that like vibrations. Okay. I said vibrations. Let us see. There are two conditions. Production of sound from vibration and oscillation. Have you heard about the word called oscillation? Ideas?
Yes, sir.
So whether oscillation produces sound?
No, it does not.
Oscillation produces sound? If no, why?
No, I don't know
I
what
just have a doubt before that.
Sorry?
I just have a doubt before that.
Ask me.
Is vibration a kind of oscillation?
That's good question. Okay, now I'll come back to you. But let me understand whether oscillation and vibration, what is the difference between oscillation and vibration?
I don't know, sir. I've never done this.
So oscillation is the to and fro movement of a body from its mean position, and vibration.
Oscillation is also that, vibration is also. So basically, okay, let's see to and fro motion of a body. Okay, if there's a pendulum and pendulums this side and again this side and coming back, and this point we said what actually? This particular point. Any
What
idea?
point? The centermost point?
This point.
I don't know, sir.
Okay. See now in production of sound, vibration basically vibration and oscillation. Okay, oscillation are same. Okay, vibration and oscillations are same. But what is the difference which I'm going to tell you? Okay, between oscillation and vibration, what are those differences? So now let us understand. Oscillation is basically a to and fro motion. Vibration is also a to and fro motion. Okay. Now for to and fro motion, let us take a simple pendulum. Okay, and if you are pulling it from one side and releasing it, okay, the pendulum will be like this. This will be the movement of the pendulum. Okay, left and right. Now this oscillation, this particular movement. Okay, this particular movement. Okay, let us understand. Okay, Akash, look at this. This is moving this side and moving this side. and this particular movement is called equilibrium state. Okay, what is that? Equilibrium state. So any to and fro motion, once at least one should travel through equilibrium state. You got me what I'm saying?
Yes, sir.
So any to and fro motion will travel at least once in equilibrium state. So this particular area is called equilibrium state, and this is traveling to and fro. Now, here the difference is, let's see the difference. What is the difference? Okay. I said vibration and oscillations are the same thing, right? Am I right?
Yeah.
So production of sound. Okay, let's write a few conditions. The condition number 1 is vibration and oscillation are same. Condition number 1. Okay, vibration and oscillation are same. Next condition is vibration. Okay, vibration occur at high frequency. Okay. We can also call frequency in other name. Just to understand. Tell me what is that? The other name of frequency?
Frequency.
What we call for frequency with the other name or the other word for frequency?
Rate of vibration.
Rate.
Intensity.
Sir, is frequency the correct spelling? Is it?
Intensity. FREEQUENCY. REEQUENCY. Frequency or intensity? QUENCY. Frequency or intensity. Okay. Now, vibration occur at high frequency. Okay. My dears, please understand. Vibration, when a particular thing is vibrating, always vibration happens with high intensity. Okay. Now, oscillation happens very low frequency. Oscillation happens at very low frequency. Okay. Therefore, the conclusion is this. Therefore, oscillation cannot produce what? Cannot produce sound. So why oscillations are not producing sound? Because oscillation happens with a less frequency or less intensity. Now, since oscillations are happening with less intensity, oscillations cannot produce sound, but vibration happens with high frequency, and because vibration happening with high frequency, vibration produces sound.
Sir.
Yes.
So an oscillation can it at least produce like a tiny bit of or nothing?
No sound will come. No sound will come in oscillation. Okay, just oscillates. Oscillates, no sound. Oscillation. Understood? So, can I have this? Now,
yes,
this area, let's see. What I wanted to tell you is so when frequency is less, no sound is produced. Okay, let's understand that when frequency is less, no sound produced. Now, in production of sound, okay, when a sound is produced, okay, let's understand this point. When a sound is produced, sound travels through the medium. What is this medium here?
This is air.
Ah. So let's understand how sound reaches us. How sound reaches us. Okay. So what I'm trying to tell you here, when the sound is produced, sound travels through the medium. So to travel, for traveling, to mean sound reaches from the center to the receiver, it requires a medium. If the air is not there, sound cannot travel. You understood what I'm saying? In a vacuum space, no sound travels. So sound need what actually? Which is nothing but air particles. Simply, we are not telling air, we are telling air particles. What it needs? Tell me. Air particles. Air
So you said
particles.
that in vacuum, a sound cannot reach us.
Hmm.
So in a vacuum, can something vibrate?
Vibration will happen, but that sound you cannot hear.
Okay.
Okay, vibration will happen. Suppose you have a material, you can vibrate it, but the sound will not come out.
Okay, sir.
Right? So when we speak, what is our medium?
Air.
Very good. Very good. Air has, okay. Air has what?
Air particles.
Very good. Air has air particles. Okay. When we speak, sound travels through air. Our medium is air. Okay. And air has air particles. Okay. Air has air particles. Now here, okay. Let's understand this point. Hope all of you noting down the required points and all, whatever I'm writing.
Yes, sir.
Propagation of sound waves. Okay, propagation of sound waves. I said propagation in the last class. What do you mean by, or what do you understand by propagation?
Transmission or transportation.
Transportation or transmission. Okay, how sound travels? Traveling, right? Travels. Am I right? Or transforming, isn't it, Bharat? Okay, so propagation of sound waves. In this, basically, let's understand this point very clearly. During transforming energy, okay? Transforming energy, during transforming energy between air particles, okay? Some amount of energy less takes place.
So basically, some energy is lost.
Correct. Okay. Some energy is lost. Some amount of energy less takes place. You understood what I'm telling? So when we are talking, see, sometimes you say, no, tell me 1 second to somebody, right? Even though we hear it, okay, I couldn't hear you properly. So what happens, like sometimes between the conditions of the air particles, okay, I will tell you what are that condition of air particle, okay? Because of the conditions of the air particle, sometimes because of the to and fro motion, sometimes some amount of energy losses. You got me, my dears? So sound travels through air particles, and to make the sound here, we need air particles, and the medium of sound, okay, reaching from center to the receiver is air particles, and air particles are the heroes here. Okay, air particle is the hero here. Because of air particle is challenging, where air particles are gaming a game, doing a game here. Some amount of energy is also lost. Okay, what happens? There are some air particles like this. Okay, let's see. it is having a gap. Okay, there is a gap here. Now some air particles are like this, in this format. So here what happens, there is a gap. Are you able to see?
Yes, sir.
In this actually, no gap. Okay. You understood what I'm saying? So this particular area, what happens? Where air gets lost. Okay, I will teach you now following area how this is being done. Okay, in the next few area which will come. How air particles are framed like this. For understanding you got it, how energy lost it? Is that clear, my dears?
Yes, sir.
Okay. So
Draw the diagram.
I will do the diagram. Before that, we have to write down few points to understand the concept of it. So let us see what happens here. I'm giving you some point. Sound is a energy. Sound is an energy. Okay. Next, the movement. Okay. The movement. The moment sound comes out. Sound comes out. Okay. From the mouth. From the mouth. Okay. This energy is transferred to the first set of particles. Okay, first set of particles. If you copy this, I will tell you the diagram now. How I'll draw the diagram and show you. What is that? Sound is a form of energy. The moment sound comes out from our mouth, this energy transferred to the first set of particles. Okay. Now, let's see. Don't keep your videos off, all of you. Sound is a form of energy. Are you all with me?
Yes, sir.
Yes.
Okay. Sound is an energy. The moment sound comes out of our mouth, the energy is transferred to the first set of particles. So what happens here? Let's see the diagram. Let us understand the diagram detailedly so that you will get an idea. Now, what is that point? Can anybody read?
Sound is a form of energy.
Sound is an energy. Next point.
The moment sound comes out, this energy is transferred to the first set of particles.
Okay. So I'm just doing with my free hand here, a small speaker. If you have better drawing skill, draw it. Okay. Speaker. Okay. Now, so here, what is this? This is a speaker. Okay. This is a speaker. Okay. Now, what is this?
Air particle.
Air particles. Okay. Air particles. Now, I have first set, second set, third set, fourth set of air particles. Okay. What has happened actually? Okay. Set 1, One, okay, all of you listen here. One hits with the 2, 2 hits with the 3, 3 hits with the 4. Okay, my dears, and they make a region like this. You got me what I'm saying? This region is basically what? Compressed region. Okay, compressed region. And this region, what we can call it as rarefaction. Rarefaction. Okay, not rarefaction, rare. So Akash, look at this. From here, the rarefaction, they make a compressed area. Again rarefaction, again compressed area. Because why? Sound to and fro motion. To and fro motion. You understood what I'm saying? Sound makes a to and fro motion. Now this gives a vibration here. And we could hear it finally. Let's see if this is the ear. The person could hear it finally. You got me what I'm telling you here, Bharat? Okay. From speaker, the vibration comes out and it reaches to the rarefaction of the air particles. Rarefaction of the air particles make a compressed area. And compressed area, obviously, when compressed area, what will happen? Density is there?
Yes.
So when density, compressed area, density will be more. When density will be more, means sound produces. Hello?
How?
Yes.
Whenever the density is more, the compressed area, what it happens, okay? This area is basically the when the sound comes out, okay? Sound comes out with a sound energy. Okay? Sound comes with a sound energy. When that sound energy hits with the air particle, sound energy become kinetic energy. You got me, my dears? When sound energy comes out of the speaker, sound energy travels to the air particles and air particles does the to and fro motion. From to and fro motion, the compressed area is made up. The compressed area will have a kinetic energy. You got me, my dears?
So won't compressed area have potential energy because after that they get released, right?
Again, see potential. When I'm talking to you, my sound energy become kinetic energy.
But that's when it
Potential energy and kinetic energy is almost the same, Nayar. What is potential energy and kinetic energy?
the energy stored in the body and the energy created when.
So the potential. See the potential. Because of my potential energy, only I'm able to speak, right? My sound energy become potential energy. Only then you are able when my sound is coming out. Okay. So my sound has come out and that is becoming potential energy. That potential energy is mixing with the air particles and air particles making a compressed area. Compressed area becoming the kinetic energy. Compressed area have more density. Okay. Are you able to understand what I'm trying to tell you? And that is why this person is able to hear. See now in the drawing, the whole area is see where the air particles are one to another having little gap. That area is called what?
Rarefaction.
Rarefaction. The other area is called what? Compressed area.
Yes, sir.
Okay. So to and fro motion is happening, and because of that, we are able to hear. Is that clear?
Yes,
so set one set. First air particle goes and hit the second one. Second hits the third one. Third hits the fourth one. Fourth and all together make a compressed area. Again the release. Again the compress. Likewise it goes.
Again the release and again they compress.
No, actually, what will happen? Few will get relaxed. Few will get reduced. Okay, when the power is transferred from one to second, one will lose the power. You got me? Second will give it to the third, third will give it to the fourth, and then there will be a compressed area. Again, the next sound will be taken by the first particle. Follow-ups of sound, continuous sound. I spoke and stopped.
Got it, sir.
Can you hear anything now? No, no. I spoke, I stopped. That's all. Continuation of talk. Talking continuation. You understood?
So,
Okay. So this part you understood now. What we have learned through this diagram? The moment sound comes out from the mouth, this energy is transferred to the first set of particles through a diagram we understood. Bharat, is that clear?
Yes, sir.
Okay. So the next point in this is, Jobin, are you following me?
Yes, sir.
Okay. Sound energy becoming kinetic energy. You would have seen that now, right? You understood that now. Yes or no, my dears?
so
Next point is particles in that diagram. Okay, particles start moving. Particles start moving in the same direction with a greater velocity. In the same direction with greater velocity. Okay. All these are pointed. These one set of particles collide with the second set of particles. Okay. And second set of particles, what happens?
Third set of
Second set of particle will collide with
Third set.
third set will collide with fourth and so on.
Yes, sir.
Okay. So how sound travels? Sound travels by transforming energy to different set of particles. My dear, understood?
yes, sir.
So
Yes,
we
sir.
can say sound travels transferring energy. Enough? Transferring energy. Now we understood now how few energy is lost. Understood?
Yes, sir. Yes, sir.
Okay. When that high frequency wave is reaching to our eardrums vibrates. Okay. When that high frequency air particles reaches, compressed air particle area is reaching to our ears, eardrums starts vibrating. Understood now?
So, but before that, I have a question. So let's take an example of a keyboard or a guitar. For example, I'm playing the C note. While I play C note and I play D note, so they both are different sounds. So are they both different frequencies or how are they?
Both are different frequency. Each see both key will have different frequency. That is why you are able to hear it as a different frequency, different
Okay,
sound.
so if you increase this frequency, the notes will go higher.
Correct.
So how does loud sound? Like how do you make the sound loud?
I will come back to that point. There is a method. Next I'll be teaching that.
Okay, so
Okay, that's good question. So particles will do what actually? What motion? Air particles?
colliding with each other and then
To and fro
continue.
motion. Because of to and fro motion, my dears, please understand this point very clearly. Keep it, store it in your brain. Now, because of to and fro motion of air particles, we are able to hear the sound. Okay? Because of the to and fro motion of the air particles, we are able to hear the sound. Is that clear?
Yes, sir.
Okay. Now sound energy become
Kinetic.
kinetic energy. Is that clear now? This part is clear? Okay. The next part is of this topic. Let's understand this. Propagation of sound waves. Why do we call sound as sound waves?
It travels in
It
waves.
travels in waves.
Last class.
To and from motion. How waves will go? To and from motion. Waves. Hana? Correct. Okay. Now, I have a question here. Person standing, okay, standing near to the speaker. Okay. How the sound will be for him?
Loud.
Very loud.
Very loud. Which means what happens? He gets sound clearly.
No, it might not be clear because he's standing too near and is. It
More
will.
sound, more frequency inserted to your eardrums. So the first will be like more. The first inserting will be more clear. Second, third, fourth, it hits back. It collapses your sound, eardrums. Okay, understood?
Yes, sir.
So we know that sound is propagating. What does propagation mean by? Once again, Jobin.
Yes, sir.
What is propagating mean by propagation?
Propagation. So
Hmm.
it's basically when
Nothing basic, yeah. Bharat, teach him.
yeah,
What
I
is
got it.
propagation? Wait, Jobin, wait. You're not listening to me. Bharat, tell him what is
I'm gonna
propagation.
tell it.
The propagation is like transmission or transportation of. If you're talking about sound propagation, and that means the transportation of sound.
How sound travels?
Sound travels like by
How sound travels? Propagation is what? How sound
travels.
travels. Okay? Joseph, remember now. Propagation is what? How sound travels.
Yes, sir.
Sound is propagating. Okay. Sound is
Yes, sir.
propagating and how sound travels. Sound is propagating through what? Now, how sound travels?
Through mediums or anything.
Through vibration.
Yeah.
Okay. Sound vibrates. Okay. Sound vibrates. Sound vibrates. So
So
how
does
sound
sound vibrate or vibration create sound?
sound vibrates. Both you can take. Vibration creates sound or sound vibrates.
Great.
Getting into air particles, sound started vibrating. Okay. Have you seen that when if you see an open speaker, Akash? Okay, let's see in car and all. If you have an open speaker, you increase the volume and see the speaker.
Vibration will be.
Vibration.
Yeah.
It vibrates very fast. The thin paper, you can see the thin black color paper is vibrating number of times. Take a small hand and place it
You
on
can
the
take an
center of.
example of a guitar.
A guitar is very good. With guitar, violin, all those things.
So another thing, I don't know if anyone's noticed, but if you place a glass of water next to a speaker, then the water in the speaker will also vibrate.
Vibrates. High frequency of sound. Compression of sound. Now, you take a small hand and place it on the mid of the speaker. You can see the hand is dancing. According to the sound. All right. So a small example, I'm just telling you. Okay. Now, so sound propagation, sound vibrates. Sound is vibrating. Okay. Air particles perform what?
Vibration again.
Little more clarity.
To and from motion.
Wonderful. To and from motion. air particles perform to and fro motion. To and fro motion. Okay. Air particles performs to and fro motion. While propagation of sound, two regions are formed. While propagation of sound, two regions formed.
He won't allow, man.
What are the two regions? Just now I taught you.
So the two
Pressing
regions
and the rare
Rarefaction and
fraction.
of rarefaction and
Wonderful,
compressed
wonderful. Which means I'm really happy you all are with me. So rarefaction and compression. Okay, what are the two regions? Compression,
and air fraction.
rarefaction. Okay. Compression means
When particles compress together and density increases with high frequency.
high frequency, rarefaction, low frequency. Okay.
Sir, in
No.
this also I have a question.
Yes.
So again, I'm playing a note C on keyboard.
There
is only one frequency, right? So how is it high frequency, low frequency? How is it switching?
Okay, see, now it depends on your. Very good. Okay, I'll add one word here. Okay, look at this. High pressure. High frequency is having high pressure. Low frequency is having low pressure. What was your question now?
But then my question is still not clear.
Ask me. See, you are telling that if you are pressing a particular key in your keyboard, if you are pressing a particular key, okay. How? Ask me that question again. Once again.
So, for example, I'm pressing the note C on keyboard.
Hmm.
It'll have one frequency, unless I go to another key and press D. So it'll have higher frequency than C. How does the single note C have high frequency and low frequency?
See, now that is the way probably the keyboard is set right. So each key is being given different sound, and the different sound is have given different pressure.
No, so that's not the question. The question over here is, you know how in compressed area frequency increases, and
No,
how in
let's see.
rarefaction
Let's see. Suppose you are pressing a key, D or C or E, something like that. Okay. Now each key would have been given a different sound. Okay, that's we need to understand.
Yeah.
Now in sound itself, there are some sound which is with high frequency and less frequency. Okay. See now, a dog is barking. High frequency sound. Can you classify it? Because dog, can you expect a dog? Wait, Prisha, I'll complete. Can you expect a dog to bark in less frequency?
No.
But so that is not
What
the
will
question.
happen to a cat?
The question is when the sound waves of the dog
I'm coming to that point. I understood. A cat. Okay, when a cat, creates a sound, how that will be? So it is less frequency. Now, when you are giving, okay, when your force is more, okay, if your force depends on the force which you are giving a key, okay, which the pressure which you are giving any keys of the keyboard, okay, there is already a high frequency and low frequency sound is set against each key. Okay, that is why you are able to play a particular song. If each key in your keyboard, if each key is given different sound, okay, based on the different sound only you are able to play a music. So each sound is being given with a different frequency.
But so that is not the question. When the sound waves of that particular note, when they're traveling through the air, and they have both, when they're in compressed, they have high frequency, and when they're in rare factor, then they have low frequency, right? Then how does it sound the same?
Okay. That's right. If if a sound, okay, uh, if I have to talk to you in this particular tone or this particular uh, pressure or this particular, suppose I speak, I can increase my volume, I can decrease my volume. Okay. Suppose I increase my volume and speaks to you, how good for you to hear. Suppose I decrease my volume and talk to you, how good for you to hear. So when the sound travels, okay, depends on the sound energy produced. Okay. The compressed area and rarefaction area differentiates. High sound, high frequency, less sound, less frequency. High sound creates high potential high potential energy to become high kinetic energy. So when you are pressing a keyboard, what I'm trying to tell you? In each key, there is a key. That key is already set with a sound frequency.
Okay, all right. So only that sound frequency reaches your ear.
Yes.
So, like a keyboard is electronic, right? But then, like if you take a piano,
Hmm.
how do they increase the frequency?
Each key is given different frequency sound.
So it's a very
So, but here, how does
tired
it go
gas
to
pressure
high
sensor.
frequency and low frequency, but we hear the same sound?
Oh, my dears, that's what I'm trying to tell you. That one particular key is set with a particular frequency, whether it can be low frequency or high frequency, which depends on the key. If the key is set with a low frequency, then it will play with low frequency.
Okay,
You
so
understood what I'm telling? Now you are
Yes,
taking
sir.
a violin, guitar, okay. Let's take the guitar. The moment you vibrates more frequency sound comes. The moment you vibrates less with your fingers, less sound comes.
yeah.
So the key is given a particular vibration mode. Key is set with a vibration mode. So if you take your piano, generally people will say that the piano is fixed with a small chip inside. Even if and eats it, chip,
No,
small chip.
it's strings.
See, a piano, inside piano, there are small.
It's a
Uh,
string instrument.
It's a string instrument. It's not a.
no, there is
So you
a
actually you are meaning keyboard.
there's a thin
There is
layer is there. Okay, inside every key there will be a small thin layer. Okay, that thin layer even an ant can eat. If it eats, that's why piano generally in the piano there would have been an instruction given: don't place nearby the foods.
But
Okay, if
what does
ant gets inside,
the thin layer do?
it collapses everything. Now you take the piano instruction and you read, you will understand.
Okay, so but what does the thin layer do? It's a hammer. It's hammering the string, and then the string vibrates. Where
Now
does
that's
it
what I'm
go?
trying to do. That's supposed to vibrate the string. So there it's a collapse everything. The key, okay, when you
Then what
press,
about the
how it
chip?
goes. No, that's not our question here. That's not our discussion here. Now, when you press the key button, it goes and it helps the string to vibrate. Okay.
Yes, sir.
Now, Akash,
Yes, sir.
the next point is here. Where were rare? So compression gives high frequency, rarefaction gives low frequency. Okay. That point understood?
Yes, sir.
Yes, sir.
The next point is here. What are all the medium of sound propagation?
All the
Medium of
All states of matter.
sound propagation. I have already discussed one medium. What is that one medium?
Air.
Air.
Gas.
Next medium,
There's a liquid. There is solid.
liquid and solid. Now, in which medium air travels, sound travels fast?
I've heard that in solid the thing
So because
travels
the
faster.
particles are closer to each
Particles are
other in
closer.
solid, so more they can travel
So,
fast.
which one it travels fast?
Solid.
Solid.
Okay, very good. In solid medium, the sound travels fast. Suppose in a school, like you have one desk, and if you keep your eyes on ears on one side of the desk, the other side, if you ask somebody, you knock it. It you can hear it in seconds, fraction of second, microseconds. You can hear it. Am I right? Am I right, my dears? Yeah.
So, but then sound won't travel that far if it's travels in solids, right?
Yeah, solid. No, sound cannot travel in solids that far.
Okay.
Depends on the solid. So one side to another side, that's all. You got me?
Yes, sir.
Okay. 5 minutes.
So can you repeat?
Can we take a break now for 5 minutes?
Yes, sir.
Yes, sir.
Okay, so I'll be back in 5 minutes.
Yes, sir.
Prisha staying back or what?
No, sir. The thing is, one of my teachers called me right now, so I need to go meet them.
Yeah, meet and come back. Then maybe after the class, I will tell you symbol. Okay.
Okay, sir. Thank you.
Sir, I have a doubt. Tomorrow we have a class, right?
Who's that? Bharat. Ah, yes, Bharat.
Can we not have that class because day after tomorrow we have exams and we'll be basically cutting our prep where we study to come here.
What is your, wait a second. What exam you have day after tomorrow?
Chemistry and geography.
Chemistry. And tomorrow's class is given to you chemistry only, I think so, morning, right?
We don't know, sir. And also some people have different exams like
Yeah, we have
IB.
chemistry too.
Whoever is having chemistry, let me see what is the schedule tomorrow.
Me and Akash have chemistry.
For IGCSE, it's a geography next.
Even we have geography.
Wait, my dears. You guys are all good students, so you should not be just skipping like that because skipping tomorrow, Sunday.
So, but then the class that we are gonna cancel like next week, Saturday and Sunday can be.
No, tomorrow max is given.
So, I think our counselor, like Miss, basically told you to cancel the exam on next week.
Next week we have cancelled.
So that is not required. Only this week.
Because next week
Next week
this
our
Friday our exams are getting over. So
So Saturday, Sunday we can contact. So tomorrow we can cancel. That's what I'm trying to tell you.
yes, sir.
basically, yeah.
Okay. So I immediately after the class I will talk to your coordinator and let you know.
Okay, sir.
Okay, thank you. Hello. Are you there?
Sir.
Yes, Bharat. So, what and all we have done now?
Propagation of sound
Propagation of sound wave
Hmm.
and
in medium of sound.
Before that, production of sound.
Yeah, production of sound.
Production of sound. Okay. Am I right? Now, the next point of this topic is little different. So concentrate, only then you will understand. Is my screen visible to all of you?
Yes, sir.
Okay, the next point is of sound. Okay. Now, what are these characteristics of sound? Okay. Yes or no? So for every item there is or every products there is a characteristics. Okay. Am I right? Isn't it? Yes or no, my dears?
Yes, sir.
Okay. So here, every sound wave, okay, every sound wave, listen, who are joined, all of you listen, every sound wave, okay, can be depicted, every sound wave can be depicted, depicted, depicted as graphical method. Okay. So the graphical method is what actually the sound wave graphical method is this one. The other one I have shown you, right? Speaker and this thing. Okay. That is one day you can draw it here and keep. Okay. Whatever I have drawn and shown to you already, the speaker and how the sound waves travels and the ears. The same thing you can draw here and keep it under that. You can make it like this. Okay. The sound waves travels in this method. Okay. Understood, my dears? Do it properly. I'm just with the free hand I'm doing. All right. Now, sound wave, okay. Sound wave can be classified sound wave classified as two. Okay. One is okay longitude wave. Longitude wave. Another one is pressure wave. Very important points. That is sound wave classified as two waves. One is what? One is what?
Longitude and pressure.
Longitude and pressure wave. Now we need to understand why sound waves are called longitudinal wave or pressure wave. Okay, my dears? We need to understand why sound waves are called longitudinal waves or pressure wave. This is what I'm going to tell you now. Is that clear?
Yes, sir.
Okay. Where is Bharat and Jobin Joseph? They're not joined as of now.
Bharat,
Sir,
Bharat
I
just
joined
came to me to copy the diagram.
because I had to write down. The diagram I had to draw from Akash's textbook.
Okay. So here, let's understand direction of sound. Okay. Direction of sound is basically what actually I told you sound travels. Okay. Sound travels from every mouth. Okay. From every mouth.
But there's only one mouth for sound, no?
Commonly I'm telling. Sound travels from every mouth to air particles. To air particles. Okay. And make what energy?
Sound energy, which will turn into kinetic energy.
Kinetic energy till the person hear it. Okay? Understood?
Yes, sir.
Now we also learned air particles travel from one set to second set to third set, third to fourth likewise. Okay? Understood that? And returns to and from motion. Am I right? Yes or no, my dears?
Yes, sir.
To and from motion. Okay. So here the question is energy transfer direction. Okay. Transfer direction is parallel or anti-parallel?
Anti-parallel.
Anti-parallel. The question is that energy transfer direction is parallel or anti-parallel?
It's anti-parallel, right?
Anti-parallel.
It's anti-parallel.
Why it's only anti-parallel?
So
Because it can be transferred in any direction.
But then sound travels. I think you mentioned
even
this before.
sound
Sound
doesn't
travels
travel.
straight, but in so many.
See, I said particle 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, to and fro motion. It goes to one transfer to second transfer to third transfer to fourth. And this particle travels back to and fro motion.
Yes, sir.
If
So is it
one
parallel
particle, if the particles moves away from us, then for continuation of sound, how it will come? Understood, Nakash? The sound particles, if moves away, okay, not coming back. Okay, then what will happen?
reflection, right?
Huh?
It's reflection, right? After it hits.
So this will be a motion like this, goes, comes back, goes, comes back, goes, comes back, goes, comes back.
Huh.
ठीक है ना? So it is parallel and anti-parallel.
It is
Okay.
both.
Energy direction is parallel and anti-parallel. Now, what happens here? Okay. This part you understood now?
Yes, sir.
Energy transfer direction, sound waves, energy transfer direction is to and fro motion. Don't forget it. To and fro motion. Now, to and fro motion air particles are parallel, anti-parallel, parallel, anti-parallel, parallel, anti-parallel. Okay. Only then sound transfers. The following for continuous sound travels. Continuation of sound happens. Okay. Now, because this is parallel and anti-parallel, okay, because this point, write down this point, very important. Okay. Because of air particles, propagation direction. Okay. parallel and anti-parallel. And anti-parallel. Okay. Sound wave is called longitudinal waves.
Sir, may I use the restroom? I'll be back in 2 minutes. Thank you.
Longitudinal waves. Is that clear now? Akash, Bharat?
Yes.
Because of particles,
Yes,
okay, because of air particles, propagation direction is parallel and anti-parallel. Sound waves is called longitudinal waves. Okay? Or pressure wave. What is that? Or pressure wave. This is basically the concept of longitudinal wave concept. In future class and all you will understand. Longitudinal wave concept is based on this. Okay. Why? Because of air particles, propagation direction is parallel and anti-parallel. Okay. Parallel, anti-parallel, parallel, anti-parallel, parallel, anti-parallel. To and fro motion. Okay. So now because of air particles, propagation direction is parallel and anti-parallel, sound waves is called longitudinal waves. Why sound waves are called longitudinal waves? Answer me. Why sound wave is called longitudinal waves? Jovin Joseph, why sound wave is called longitudinal waves? Sorry, why sound? Sorry.
Pardon?
Why sound wave is called longitudinal waves?
Longitudinal waves because sound travels in like a straight way, so it's called longitude.
No. Because of air particles, not sound. Because of air particles, propagation direction,
Yeah, but it's
not sound
also
waves.
always travels straight, like.
Here, remember air particles, my dear, not the
Oh,
sound
okay.
wave. Because of air particles movement, parallel and anti-parallel, sound wave is called a longitudinal wave. Air particles movement, not sound wave movement. Got getting me? Because of 1 to 2, 2 to 3, 3 to 4, again back. You got me, my dears? Because
Yes,
of
sir.
air particles propagation, air particles. That's why I underlined this point. Because of air particle propagation direction, parallel and anti-parallel, sound wave is called longitudinal waves. Is that clear?
Can you repeat that?
Because of air particles propagation direction, parallel or anti-parallel, sound wave is called longitudinal waves or pressure wave. Why pressure wave? Because it creates a two section, rarefaction and compression. Compression is pressure, na?
So what did I miss?
Sure. This point.
Just what's written on the board?
What I said, why sound wave is called longitudinal waves. Okay. Why sound waves are called longitudinal waves or concept of longitudinal wave. What is the concept of longitudinal wave? Is nothing but because of air particles propagation direction parallel or anti-parallel, sound wave is called longitudinal waves. Are you clear this point?
Yes, sir.
Yes,
Are you
sir.
clear? Not sound wave is propagation, air particles propagation. Remember, because of air particles propagation direction, okay, parallel or anti-parallel, sound wave is called longitudinal waves or pressure wave. Why pressure wave? Because it creates two areas, rarefaction area and compressed area. So compressed area is pressure, rarefaction is also pressure. Rarefaction area is less pressure, Compression area is high pressure. है ना? Understood or not?
Yes, sir.
Yes, sir.
So now tell me why sound wave is called longitudinal waves, all of you?
Because of air particles propagation direction.
Air particles propagation direction parallel or anti-parallel. Okay? To and from motion. That simply you can write also. So okay, because of air particles propagation to and from motion or and parallel and anti-parallel. ठीक है ना? Understood or not?
Yes, sir.
Yes, sir.
So here to understand pressure wave in a little bit different way. Okay. There are two regions, right? What are the two regions we discussed in sound wave?
Rarefaction and
Compressed and
compression.
Rarefaction. So we can say that collide region 1, okay? Particles are away. 2, है? One region particles are away. Another region collide region. Collide region is what?
Compressed, basically.
Particles are away. That region. That region.
Colliding is when particles are away.
No, collide region is particles are close. Density is more. Collide means what?
Yeah, close to each other, they are colliding.
See, this area density is more. And this area density is less. Sorry. Okay. This area density is less. Isn't it? Isn't it, my dears?
Yes,
So this collide area is high pressure. This is low pressure. Isn't it? Yes or no?
Yes, sir.
Correct now?
Yes.
Yes, sir.
Okay. Is that clear now?
Yes, sir.
Okay. So why sound wave is called longitudinal waves or pressure wave?
Because it's parallel, anti-parallel, and the direction of
Air particles direction propagation. Okay, air particles propagation direction is parallel or anti-parallel. That is why sound wave is called longitudinal wave. In longitudinal wave, there are two areas. One is collide region, other one is particle are away. In collide region, high pressure. In particles are away region, that is rarefaction area. In that, low pressure. Understood?
Yes, sir.
yes, sir.
Okay. Next one is this point to understand. In sound wave, okay, in sound wave, repetitive region is coming. Repetitive region comes. Why? Why? In sound wave, repetitive region comes. Why?
Yes, sir.
Because like you explained, once it compresses, it
Okay.
again
See one area. Area 1, low pressure. Area 2, high pressure.
Does it have
Okay.
anything to do with diffusion?
Again, area 1, low pressure. Area 2, high pressure. Okay. My dears, travels, comes back, travels, comes back, travels, comes back, travels, comes back. Okay. Repetitive region. Okay. What is this? Repetitive region. So high pressure, low pressure, again low pressure, high pressure, high pressure, low pressure, low pressure, high pressure. Got me?
Yes, sir.
Okay. Since pressure, okay, low and high. Since these two pressure is happening, the sound wave is called since low pressure and high pressure is happening,
Pressure
sound
wave.
wave is called pressure wave.
Sound wave.
Yes, sir.
Okay, since low pressure and high pressure is happening, sound wave is called pressure wave. Is that clear? Why sound wave is called longitudinal waves?
Because it's
Because
back
it
and forth motion.
travel because of the air particles propagation direction,
So
parallel
they
and
are parallel
anti-parallel.
and anti-parallel.
So sound waves are called.
Longitudinal waves. Why sound waves are called pressure wave?
It creates high pressure and low pressure in compressed
And
region and
sound waves creates repetitive region. In repetitive region, pressure wave, low pressure, high pressure, low pressure, high pressure. Likewise, it comes with a repetitive region. Okay, is that clear, my dears?
Yes, sir.
Okay. Now, a general question. Okay. Now, why sound waves in graph we do like this? Why not like this? Why not like this?
Because they only travel like the first way.
Why?
It is not a stuck movement. It's a very smooth movement of sound waves.
Okay. Suppose I take you to keep an air particles. Okay. Take an air particle like this. Okay. Now place it on the paper, on A4 sheet. Okay. You keep this air particles here. Okay, my dear. Okay. Understood? I have told you to take a simple logic.
Yes,
Take an
sir.
A4 sheet, keep an air particle here. Now slowly pull this paper. What will happen? What will be the movements of this? All right. So the movements of air particles are taken like this, to and from motion. Okay. Now this is only taken and placed like this. That's all. This movement is taken. That's this movement. This movement is taken and placed like this. Is that clear?
yes, sir.
Okay. Now the point of which topic we are now? Which topic we are now?
Sound. Direction of sound. And then we are next.
No. Prisha, where are you? Where is Prisha?
here.
I can't see you.
Two types of sound.
Can I
and
try rejoining? I don't know why it's not happening.
No, keep a video off on, it will come. Or you can rejoin immediately.
I'll turn
See,
it off and turn it on. Just
so now, Akash, we were at the topic of characteristics of sound.
Yeah, two types of the sound and
Okay.
So
So
can
in
you see me now?
characteristics of sound, immediate important points. Okay, all of you must note down this point. The points are like this. Every point, okay, every point on the sound, every point on the sound where sound wave, okay, every point on the sound wave is a particle movement, is a particle movement. Point number one. Point number two is, I expect all of you to note down this point. When there was no sound, when there was no sound, particle was standing at equilibrium position. Particle was standing at equilibrium position. Okay. Next point is sound energy. Sound energy comes in. Sound energy comes in. Particles start going. Particles start going forward and coming backward. And coming backward. Copy this point. I need to write 2 more points. Copy.
No, sir, no, sir, no, sir.
Yes, sir.
Every point on the sound wave is a particle movement. When there was no sound, the particle is having, or particle is at equilibrium position. Sound energy comes in, particles start going forward and coming backward. When somebody starts speaking, sound energy comes in, okay, particle starts moving, coming and going forward. Am I right? Going forward, coming back, going forward, coming back, to and from motion. Next point is, hope you have copied this. Can I rub?
Yes, sir.
Can I rub
Yes,
this?
sir. Yes, sir.
Okay. The next 2 points of the same thing, following the points. Okay, following points of the same condition. Waves tells the displacement of the particle. Okay. Next point is y-axis. Coming to max slowly. Y-axis displacement of particle. Next point is maximum displacement equal to peak points of wave. I will show you through a graph these 2 points, y-axis displacement of particle and maximum displacement equal to peak points of wave. Peak points of wave. Copied this? Gautam is not telling anything. Copied? Okay. Prisha,
Just
copied?
wait 2 minutes. Just wait 2 minutes.
Okay, Gautam. Y-axis displacement of particle and maximum displacement peak points of wave. So I'll show you through a graph. Can I rub this? Can I rub
Yes, sir.
this?
Just yes, sir.
Okay, now let's see the graph so that we'll understand better. Let's see. Okay. Okay. So which is x1? X, y. Anna? Yes or no?
Yes, sir.
So this is to and fro motion of sound wave. Okay. This is the peak. Anna? This is peak. Yes or no?
Yes, sir.
So what was the condition? Y-axis equal to
Maximum. No.
displacement of particle, last condition, and maximum displacement is peak point. Okay, maximum displacement is
Is the peak point.
peak point. Okay, now this point, what is this point? X-axis.
X-axis.
Now what is this tells? This is y-axis peak point. X-axis tells us what?
Displacement.
Equilibrium position. Okay, x dash only displacement. X-axis tells us equilibrium position, which means what? If particles are not moving. If particles are not moving. Anna? Understood now? Now, Akash, any waves, okay, take any waves, at least once they should pass through equilibrium position. Okay, any waves should pass at least once of their journey, one single journey. What is one wave? One wave is what actually in this picture? This is one wave.
Going from, yeah.
This is one wave. Okay, start down to equilibrium. One wave is what? Up, down, up, down. Understood now? So
Yes,
one wave is this. This is one wave. Understood now? So one wave at least pass through once in y direction, y-axis, x-axis. In y-axis, it will be in the peak. X-axis, it will be in the equilibrium position. Okay, my dear? Understood now?
Yes, sir.
Yes, sir.
So that's what I said. In suppose we are hanging a pendulum. Okay, it goes up, comes down, and this position is this position is what? E.
Which
Equilibrium position. Equilibrium position. So anyway, this is oscillation, no? This is oscillating, right?
Yes, sir.
Oscillating. So in the oscillation position, any object in the oscillation or wave position should at least travel once through the equilibrium position. Got my dears?
So, but this is a vibration, right?
Oscillation and vibrations are same.
But vibration is faster.
Oscillation and vibrations are same. Just in the beginning of the class today, I told you.
Yeah.
Oscillation never makes sound. Vibration makes sound.
So how does this come in oscillation? So if oscillation does not make sound, how does the sound waves come in?
See, vibrating, any item vibrating will have high frequency. Simple to understand. Okay? Any material vibrating will have high frequency. When a vibration happens at high frequency, high sound. When a vibrating is with low frequency, low sound. That's all. In oscillation, okay, oscillating will have low frequency. That is why no sound at all. Okay. Density. There's one more word we have learned for frequency. I told you one more word.
Yes, sir. Intensity.
Intensity. intensity. Okay. Now this point is also called, okay, peak point amplitude. Okay. Here it comes. You would have seen for any speaker when somebody is doing a stage show, people are bringing an amplifier. Am I right? Amplifier. What did amplifier do?
Fasten the sound, you said.
Amplifier increases the
Increases.
frequency of the sound.
So if it increases this frequency, it will go higher.
Sound energy increases.
Okay.
Sound energy increases. And sound energy travels to more places. Sound energy reaches to more places. So amplifier increases the frequency. Keeping a mic through mic, it is taken. That is taken with some frequency. That frequency is increased through an amplifier. Amplifier gives that increased frequency to a speaker. Speaker gives high energy frequency outside.
Yes, sir.
You got me?
Yes, sir.
Anna? So amplitude, what did amplitude do?
It increased frequency.
From equilibrium position, okay, my dears, from equilibrium position, it gives maximum displacement. Okay.
Yes.
What it do? Amplifier gives maximum displacement of a sound from equilibrium position. So maximum displacement equal to peak point. Anna? That's what I told, right? Maximum displacement equal to peak point. You would have written that content in the last, before this diagram. So amplitude does maximum displacement. Is that clear? Got me? So amplitude maximum displacement of the medium particles from the equilibrium position to the mean position. Is that clear now? Any doubt why you are all looking very dull? Is that clear?
Yes, sir. We understood.
Understood now?
Yes, sir.
So in characteristics of sound, what are the main points we have to recall? Cluster wave, longitudinal wave. Okay. Then repetitive region, high pressure, low pressure, colloid region, compressed area, rarefaction, less fraction, rarefaction, less pressure area. Then what? Then what?
Then about the waves, graphs and all. Hello. Yeah, x-axis.
Sound wave from whenever sound wave comes out.
Y-axis depends on what they represent.
Whenever sound comes out of the mouth, sound energy make into kinetic energy. Sound energy become kinetic energy through air particles. The y-axis tells us in sound wave, y-axis gives us the what? Displacement of particle. Maximum displacement of the
y-axis is the peak, right?
No, peaks. Maximum displacement. Maximum displacement. X-axis is giving us equilibrium. Y-axis gives us the maximum displacement, which is peak point. X-axis gives us the equilibrium position. Amplitude works in sound wave in such a way that from equilibrium position, it gives us the maximum displacement. Got me? Is that clear?
Sir. Yes, sir.
So now what I'm going to do is I'll stop here. I don't want to extend now. You guys do well for your exams on Monday. And till Friday, you said you have exams. So I'll request your coordinator and our teachers also that tomorrow we'll not do the class. And we'll do again next Saturday, Sunday. Is that okay, my dears?
Yes, sir.
Yes, sir.
Okay. Is that clear? So whatever
Yes.
I taught you today, see, every time, see, physics is based on the condition of the student. If a student really wanted to do physics better, then student will do work, student will listen to the teacher, and student will work as per the direction of the teacher, and he or she will also develop some energy to learn physics. If you cannot understand physics, then which means that somewhere you're blocked with maths and analytical areas of thinking. If that is the case, physics won't work for you. So if you are really interested in physics, physics can give you a lot of magic in your career. So learn physics accordingly.
Okay,
Anna?
sir.
Yeah, thank you very much. We'll see you in the next class, next Saturday probably. Thank you very much, all of you. Okay?
So, on Sunday will we have a class?
No, tomorrow hopefully I'll cancel it.
Okay, sir.
I'll cancel it.
Okay, sir.
Okay.
Okay, sir.
Yeah.
Thank you.
You guys wanted, you guys told me that only, no?
Yes, sir. Yes, sir.
So I'll do
Yes.
that. Yeah.
Yes, sir. Thank
Okay,
you.
sir. Thank you, sir. Good night, sir.
Good night. Good night. Good night.